Today's lecture we're going to be going over databases. Now, the database course was not a prerequisite for this course, so you won't have to know any SQL or how to access or work with databases. I'm going to give you everything you need in that respect, but I do want you to learn what it means to connect code to a database. And so before we get into any of that, I do want to talk about XML, because a lot of the things stored in .NET deal with XML. You'll notice that our XAML is an XML-based language. When we return data from a database, we're going to work with something called a DataSet, which is an in-memory sort of table from a database, but it's XML-based. So just real quick, let's look at an XML document. And again, you just be fairly familiar with it. So we've got our XML tag at the top. You'll notice XML, it's a self-describing markup language. It stands for XML or Extensible Markup Language. It's all over the internet and applications nowadays, and basically it's just a self-describing language that has tags, and within these tags you can also have attributes. And so you'll notice here's a letter tag, and if we open this in Visual Studio you can see that we can open or close these. Within a letter we have as many contacts as we want, or these paragraphs, or closing. So you can see there's just different way that they've structured this document. And for example, there's a contact object here, and you can see there's name and addresses and city and things like that. So just kind of wanted to show you the XML syntax. You just need to be basically familiar with it, and that's about it. So the next thing I want to go on to is just a background in databases. So this is going to be a little bit different than we normally do our lectures, in that I just kind of want to talk about everything behind the scenes first, and then we'll go over the code. So first, in .NET we have something called ADO.NET, or ActiveX Data Objects. And these are the classes in .NET that we're going to be using in order to connect to a database. So if you hear someone say ADO.NET, that's what they're talking about. So within this ADO.NET, we have some different namespaces that we're going to go through. So for example, System.Data is the root namespace, and it's going to contain the other namespaces and classes that we're going to actually use to access databases. So for example, today we're going to be using one called System.Data.OleDb and System.Data.SqlClient. These namespaces contain the classes used to connect to the databases. And again, as we go through these more and more, it'll make more sense. So the next class I want to talk about, because remember these are namespaces. Within those namespaces, we've got System.Data, and we've got a class called OleDb. Or sorry, this is the namespace that contains classes to work with any dataset. Now, we're going to be using OleDb, or the classes contained within this namespace. Now the reason for that is it's sort of generic, and we could connect to many different types of databases with this, but since we're going to be using Microsoft Access, this is the classes that you would want to be using or within this namespace. Now if you were connecting to an Oracle database, there are similar classes that you would use, but the code would be structured very similar to how we do it. So it almost doesn't matter which database you're using if you kind of understand the basics of the code we're going to create in just a moment. So also, we have this System.SqlClient namespace. It's going to contain the classes optimized to work with SQL Server. So again, for our assignments, we're going to be using this one, but in the future, if you were using an SQL Server, you would use the classes in this namespace. And as we go through those classes, you'll see that they're named exactly the same. Again, if you were using like an Oracle database, Oracle itself actually provides you these classes. So you would download them from Oracle and you'd use those instead. So let's talk about a data set now. So a data set, it's an in-memory table from a database. And what it is within a data set, there's data tables. So data set is a class. We're going to create objects from it. Within a data set, so think of it as a collection. It's kind of like a list, but it's actually has an array of data tables. So it can have as many data tables. Just like a database can have as many tables as you want. A data set can have as many data tables as you want. Within those data tables, it mimics the relationship of a database. So you can actually have those tables be related to one another. And these are all in memory. So it's what are called connectionless, is what a data set is, where there is no connection to the database. You make a connection to the database, pull the data back into a data set, and now you close that connection because your data is now in the database, in this data set. Each of those data tables are made up of data column objects and data row objects. So these are other classes that are used within the data set to mimic the columns and rows of a table. So now, as I mentioned, data sets are disconnected, and that's very important to understand because as you manipulate data sets, you're just manipulating them in memory, and you would actually have to do some extra code in order to submit the changes back to the database. So now, this is a key class that we're going to be using that's part of this System.Data.OleDb namespace. This class is called OleDbConnection. It's going to hold all the information needed to connect to whatever data source you're trying to access. And we'll take a look at those connection strings in just a minute for that. So the next class is the OleDbDataAdapter. So what a data adapter allows you to do is it allows you to use your connection to populate a data set. So the data adapter is what actually says, okay, I've got this connection, so I know how to get to the database. Now let's query something from the database and pull it back into the data set. Then the last class we need to know about is called the OleDbCommand. And so the command is the object that we actually contains the SQL so we're selecting data from a database, we're deleting data from a database, or updating the data. That is contained within this command class. Now, I understand that we're just sort of reading this on paper and it's a little bit confusing, and it is. This is complicated stuff. And so it takes a little bit to get used to. And honestly, what I generally do is I end up writing a class, like a data access class, like we're going to do in just a second, that contains all of this code. And I only write it at the beginning of every project. So it's like I write it, I make it rock solid for connecting to a particular database, and then I just use that class. And that's kind of what we're going to do here, is I'm going to show you how I put it together, and then you're welcome to use this new class in our course. So let's go ahead and go through that now. So I'm going to take a look here at an example called the DB class example. And what we're going to do is we're going to walk through the CLS data access class. Now again, you're more than welcome to just take this file and use it in any of our database assignments. Remember, we don't have to actually know about how to work with databases. I'm going to give you all the databases for you. I'm going to give you the SQL strings that you need. The only reason we're using access is because it's very easy to pass around. Of course, it's not the database you would probably use for any large application, but it works just fine for what we're trying. And it doesn't matter. The kind of database you're using doesn't matter. What you care about is the C# code. That's what we want to learn. So here we go. Let's go into our data access class. Now, first thing we're going to want is a connection string. So this connection string is this long string right here. And there's various ways, oops, kind of moved me there. There's various ways of creating this SQL, or sorry, this connection string here. But this is for the general Microsoft access. In the help documents, I've given you these connection strings for the various kinds. But for here, essentially what it's saying is that, okay, we're using the Microsoft Jet OleDb 4.0 provider. The data source equals, and then from here to here is just the path to our database. In Access, it's just an MDB file called books. And so in our project, I've added this books.mdb file to our database code. So you'll notice that that's just in the bin directory of our database examples. So if we were to go into our database code, you'd see that in the bin directory. So now let's come back to our next method here. This method is called execute SQL statement. And so what that's going to do for us is take in an SQL statement, execute it, return a data set, and also return us as a parameter how many values are returned in our data set. So that's what we're going to do there. So let's take a look inside the code here. So the first thing we're going to do is we're going to instantiate a new data set. Now you notice this is just class System.Data.DataSet. Now you'll also notice that I'm getting some compile errors here. So before I go any further, I want to show you how you can get rid of these compile errors. So I created a .NET 6 core application, and that's why I'm getting these. If you were to create an older application, this would actually just work. But what we have to do is we have to come over to our dependencies, right click, select Manage NuGet Packages. Under the Browse, what we want to do is we want to search for OleDb, and make sure you're under Browse and not Installed. See how it comes up with System.Data.OleDb. So this is just allowing us to download the DLLs that we need so we can access all of the code that Microsoft has already written for us that we just talked about over here. So we're getting all of this code from Microsoft, importing it into our application. So you just click Install, click OK, and then what you'll notice is that over here now, under Packages, we've got System.Data.OleDb. So now I can save my project, come back over here to my data access class, and you'll notice that now it understands what OleDbConnection is. And you'll notice at the top, I've added this using statement, System.Data.OleDb. So we're saying inside this namespace, I want to use these classes. So as we come down here, this is a new concept that we haven't learned about before, and that's the using statement. So first, let's take a look at inside the using statement and what we're doing here. What this does is this uses that class we talked about, OleDbConnection, and it just instantiates it. So let me take this outside of this using statement, and maybe this will look a little more familiar to you. All it does is instantiate this connection object, and it passes in the connection string that was created up here, essentially saying, hey, here's a connection to this Access database. That's all that does. Putting it inside of a using statement, that is very helpful, because what happens is it's likely that your code within here is going to generate an exception. Happens all the time. If you didn't create your connection string correctly, or you couldn't access the database, or you had a bad SQL statement, any of those would make this throw an exception. Well, the problem is a lot of people forget that they want to actually close this connection if some kind of error happens over here. So what the using statement does is, for this class, it will implement the iDisposable interface. So if you remember, we learned about interfaces, and interfaces just mean we sign a contract with a compiler. And here's what that interface looks like. It means that you must implement the dispose method. So what does the dispose method do? Well, it frees and releases unmanaged resources like database connections. So what the using statement says is, okay, from this bracket to this bracket, if this object throws an exception, automatically call the dispose method within this object. So it's exactly the same as saying connection.dispose. Now you could do this manually, like if you were to put this code inside of a try-catch block, kind of like here, and if an exception was ever thrown, you could manually do connection.dispose. But the using statement does it for us. That way we don't even have to worry about it. It just automatically closes this connection, you calling the dispose method. So any object that implements iDispose you can put in the using statement. That also goes for the data adapter here. So let's walk through this again. So we're creating our data set, which is going to hold, remember this is an in-memory database. We instantiate the connection to our database. Then we instantiate our data adapter. The data adapter is what links the database to our data set. First, we have to open our connection to the database. So this uses our connection object. So again, if there was a problem with this connection string, this would normally throw an exception. But because it's in this using statement, we know that we're guaranteed to close that connection via the dispose method. Next, we're going to set up the properties in our adapter method to make sure it does what we want it to do. And in this case, we want to execute a database SQL statement in order to query the database with some data. So we set up this adapter.select command. So if I highlight this, you can see that it's an OleDbCommand. We instantiate that new command, pass in the SQL statement, and we also pass in the connection to the database. Because remember, the adapter, it needs the SQL statement and it needs our connection object so that it can query the database. Timeout essentially says, take as long as you need, but you could, if you said, hey, you don't want it going any longer than 10 seconds or whatever else, you could actually put a time here. Next, we say adapter.fill, and we pass in our data set. So we're saying use our adapter to fill up this data set. So if we have a select statement that says select all from a given database, this executes it. Then next, what we can do is we can use that data set, we can access the tables, and notice how it's actually an array. So if I were to say ds dot, you can see there's all kinds of different methods and properties we can get, but we're interested in our data tables. So you can see here this is a data table collection. So which data table do you want? Well, in our SQL statement here, we're just going to be querying one data table, so we know it's always the first data table. Next, we can get all kinds of information about this given data table. And so I recommend you go through here and kind of familiarize what you can do with a data table. In this case, what we're interested in is we created a method, remember, to actually return how many rows are in our data set. We didn't have to do this, but it's just kind of helpful, and that way you can check this one parameter and not have to worry about looking inside this object if this SQL statement actually returned you some data. And so that's why I'm saying data tables dot rows, and you can see this is a data row collection inside of here. So if we wanted to access a given data row, we could do something like this, and that would return our data row for us. In our example, all we were going to do is we're just going to return our data set. So by setting this, that returns it out this parameter. So the point of the execute SQL is to pass in some sort of select statement, select all from authors or select all from passengers, something like that, where you're going to pull data out of a database and return it in a data set. So next I'm going to be talking about what's called execute scalar. So what execute scalar does is it's going to execute an SQL statement that results in just a single value being returned. So notice that this one returns a string, and so maybe you're selecting the ID or just the seat number or the social security number, something like that from a person. This is the method you would want to do. You don't need a whole data set worth of data, just a string value. So it's going to look very similar to what we did up above. So you'll notice we have a using statement for our OleDbConnection. Same thing for our data adapter. Open the connection, set our command here, but now instead of doing adapter.fill in our data set, now we're just going to say adapter.selectCommand.execute scalar. Just a little bit different way of doing things where we know we can get a single statement. Now, this particular method returns an object. So we have to put it in an object, make sure it's not null. If it is null, we just return a blank. If it's not, we just say object.toString. And that's how we get a single value back from our database. Next, we're going to talk about a method called execute non-query, where you pass in the SQL statement. This was going to be like a delete SQL statement or an update SQL statement, where we're just going to be modifying the database, but we're not going to be returning values. However, our method returns an int, which is the number of rows affected by our SQL statement. So in this using statement, we set up the connection. Now you'll notice that down here we don't use the data adapter or data set because we're not actually returning any data back. So we just set up our connection, instantiate our command, and then say command.execute non-query, and then return the number of rows that our execute non-query affected. And you can see that that method actually tells us how many rows. So if you did an update statement and it affected 3 rows, that would return the number 3 here. So what we've done here is we've created a class called CLS Data Access that we can now use in the future. Let me collapse this down so that we can execute an SQL statement and return it in a data set. We can execute a single statement and return just a single value, or we can execute something like an update or delete statement. So now in our course, you can use this class and just instantiate it and now call these methods, and we can now, it will connect to our database. And this is that in-tier development we talked about before. So notice this is my data access layer in my in-tier development. So think about in the future now, let's say we change our database to an Oracle database. So all we would have to do is rewrite just a little bit in this class here. And so rather than using the classes from this System.Data.OleDb, we would be using Oracle's classes, and it's very, very similar. And all the rest of our code would stay the same because it's just using the data access class and saying execute SQL. That code doesn't care about where this could be getting data from a file for all it cares. So in the future, you can swap out databases, and all you have to do is update this one level of code and you can move on. So now let's go ahead and let's move on to where we can take a look at some database code exactly. And so what I'm going to do is I'm actually going to open up this data access, or this access database, and you'll notice that we have things like authors, author ID, first name, last name, and there's publishers and titles and things like that. So over here in our application, we're going to be setting up some SQL statements. You'll notice that here we can submit a query, we can execute a non-query, so you could probably see that this is going to use that execute SQL versus the execute non-query and the statement. This is going to execute our scalar SQL. This is going to pull some values from the database and just put them in a list box. This is just going to fill up the combo box. So let's just walk through the code for each of these. So up here we've got a DataGrid view, and just this is for Windows Forms. In another lecture, the WPF Advanced Concepts, we'll actually be talking about how to fill up a data grid for WPF. This lecture is about databases. And so while we're pulling back lists and objects and things like that, that's the code we're focusing on, is the database and pulling data back. How you fill up these data sets is a different concept, and so other lectures will really be focusing on that. So let's go behind the scenes here now. So you'll notice I've just got my data access class, and then I always instantiate that in the constructor. Normally you'd want to try catch block here just in case this threw an exception. So now that we've created this DB class, all we have to do is use it. So imagine in the real world that you had a coworker create this class, and maybe this was 10,000 lines long and it was extremely complicated, which you just saw it was pretty complicated, but you don't care. They just give you this code and you start using it for things like this, right? db.execute.SQL. You just care, you write one line of code and you don't care about the implementation underneath that someone else took, to execute this particular lines of code. You just care about using the class in order to get the job done. So let's take a look at submit query. So the submit query, we're going to create a data set because we know we're going to return our data. We're also going to return the number of values. So we just say db.execute.SQL. We pass in whatever SQL the user gave us in the text box. This returns how many records will be in our statement. Now we've got this data set. So what we can do now is for our data grid right here, we can say our data grid, it's data source. So where is the source of our data? What data should be filled up in this data grid? Well, that's our data set here. And oh, by the way, it's data member that is where the data is actually located, is in this data table. Because remember, we could have lots of data tables within this data set. So this is telling us, hey, what you actually want to pull the data from is this table. Now the next one, this update click, which is our button here, you can see that we say execute non-query, and we pass in whatever the user has given us, and then that returns the values, and then we just display how many rows was affected. For execute scalar, you can see here I've just hard-coded an SQL statement. Now, if you can see, just return the first name from authors. So if I come back to our authors database, we're just saying return the first name for this given author. And in this one, it's author ID 2, so it would return this Paul Dietil. Now here we're going to call this command fill list box click, where I'm just saying, hey, give me all of the authors in our database, and then I'm going to loop through this list here, this list box, and I'm just going to add this string. So I'm going to create a string that I'm going to add. So you'll notice I say in my data set, access the first data table, then I access the rows. Now this is a collection of rows. So what I'm doing here is I'm looping through each of the rows inside my data table. That's why I've got my I here and my I here. So I'm just looping through each of the rows. I know my columns here, since I did select all, you can see that the first one's going to be author ID, the second one's going to be first name. So because it's 0 based, 0, 1, that returns first name. Concatenate that with, just showing you a different way to do that, the same row, but now we're getting item array sub 2. So you can see I'm just showing you two different syntax for how to pull this out of this multi-dimensional array. That's all it is. So in this case, I'm pulling out the last name here. So I'm pulling out the first name and last name from our database, creating a string, and adding that to my list box. Now the one thing I want to say is I've tried to keep this really simple and focused on the database code, but all of this you would never want to put any of this behind your user interface. Instead, all of this should be in a business logic class, and then you'd return a list of these objects and bind that to your list or your combo box. But again, I'm just trying to keep it simple here. Fill combo box, again, same thing. All of this code would normally want to be in a business logic. Here I'm keeping it simple. Execute everything from authors, doing the same thing and just filling up the items in the combo box. And we'll show you better ways to do this in other lectures. Now let me go ahead and try to run this and watch what happens. And this will be a common error that you may also get. Oh, I changed it back. So what you may need to do is, I think I've already changed this setting, that's why it actually worked for you. If you get a compilation error, you may need to come in here and you'll see something like this, and you may need to change it. You'll have to do like new, and you'll have to say x86. Oops, we don't want ARM, we got x86. And then do that, and you'll see how it says x86 right here now. That's how you'd get rid of that error if it runs and you have a compilation error. And so you can see now if I do this, it'll actually pull out this data from the database and fill up the various things, or extract one value. I don't want to have to write SQL statements here. But you can see we're querying that database that's stored in there. And so what's the point of that? Well, up to this point, we had no way of saving the state when the user closed down their application. Everything was in memory. We've now learned the concept of how to save the data away and pull it back up. So let's take a look at another application. So you can see I've just imported this exact same data access class. Now if we were using a different database, like if you're using it for your airline reservation system, you have to use the database that I gave you. So you have to put that MDB file in this same directory. So for example, here's that database class example, and you'd have to put this books.mdb. If it was the reservation system, you have to put that one in behind the bin, where your exe is located. So now this one, what we're going to do here is we're going to pull out some data from a database into a data set, and we're going to manipulate it all in memory. And so we're not actually going to be updating the database here. We're going to do everything in memory. So let's go ahead and run the application. Let's take a look at what it does. So you can see that as I select here, I'm handling the onChange event and then showing you which item is selected. So see how helpful this is? So I click here, and now the user says, oh, what I really meant was I'm going to change their last name to this. Now there are ways that you could manipulate the data down here, kind of like an Excel spreadsheet, but that's kind of an advanced concept. So I thought I would do it this way just to show you a simpler way. Or if you want, add this, add at current row. So you can see how it added in that user, and if we wanted to, we actually delete the user at the selected row. And so just a couple different things. Now if I close this down and run it again, you'll notice that all the data comes back. Why? Because I query the data from the database and then I manipulate it in memory. So let's take a look at that now. So I have my data access class. On startup, I instantiate the data access class. Now again, all of this code would normally be behind in a business logic class, but we're just going to put it here for now. So here I can see I'm selecting the author ID, first name, last name from authors. Again, I don't expect you to understand SQL, but it should be readable, where I'm selecting these columns from this table. So I'm saying I want to get the author ID, first name, and last name from authors. And that gives me all of them. And for your assignments, I'm going to give you all of the SQL statements you need. So this executes that. Now my data set contains all of the authors. So now I just want to show you some different things you can set. So for example, I can set the table name if I wanted to. Here's my DataGrid view. So when my program runs, I want my data to be bound to this DataGrid view. So how do I do that? Well, here's my data set that has all my data. I bind that to my data source. And then I say, okay, my data member, set that to my table name, which I set up here. You can see here, I'm just saying, okay, in my DataGrid view, select the first row. That's all that's doing. So you can see if I run it, see how the first row is selected there? That's all I'm doing. The next one, I'm showing you that there's different ways that you can allow or not allow sorting for your columns. So generally when you're showing a DataGrid view, you want to customize it to be as helpful as possible to that end user. Sometimes it makes sense to have to sort your columns. So that's kind of what I'm going over here. Now you'll notice that the data set itself contains author ID. Well, this is a database ID. The user does not need to see author ID. We want it available to us, but the user doesn't even know what an author ID is. They just care about first name and last name. So notice how I'm hiding this column. So when I run this, there is another column. I'm just not showing it to the end user because it's going to be like 1, 2, 3, or it's going to be some sort of ID that's meaningless to them. But it's a unique row in our table that we need. Next, inside of our data grid, I'm going to set the second and third column. Why? Because column 0 is invisible. And I'm going to set that header text to first and last name. So when I run this, you can see that it actually shows me first and last name up here. So that's what happens when the program first starts. So now let's take a look at DataGrid view current cell changed. So if you were to click on your DataGrid view and come over to events, you can see there's lots of different events that you can handle. And so if an individual cell was clicked or row was clicked, mouse down, I've chosen to use current cell changed. And what that allows me to do is every time the user clicks between any of the different cells, an event gets raised, and now I can put that information up here, and I know which row has been selected. So first thing I always want to do is make sure that the current row is not null, because it's actually possible. You notice how there's this blank row down here? Well, we don't want to do anything if that row is selected. So we always want to make sure that it's not null. Now this is deleting. I'm going to skip this for just 1 second and come back to it in a minute. So just forget about it for now. Next, we need to figure out, hey, which row was selected? Well, there's two different ways we can do this. We can say DataGrid view 1 current cell dot row index or DataGrid view 1 current row dot index. Two different ways, gives you the exact same value. Now what we're going to do is we're going to make sure that it's a valid row. Again, just always being careful here. And then what we're saying here is that, okay, in that text box, grab my data set. We know it's the first table. Which row? Well, it's this iRowNum, because remember our DataGrid view is bound to the data in our data set. So if we know what the selected row is in our DataGrid view, we can access that row within our data set, access the column that we're trying to pull out, and set that to the first name here. So see how this is the column that contains the first name. This is the column that contains the last name. So that's how we're able to extract that data from our data set. Now this update click button, this one right here, so we pull in the information that the user has typed into the text boxes. Here I kind of want to show you that when we're updating data in our data set, this does not work here, this sort of syntax where we're going to say rows, and then item array, it actually has to be this syntax here. Don't ask me why, but that's just the way it is. So when you're updating data in a data set, now remember, a data set is an internal memory. We're not messing with the database anymore. It's disconnected. But you are able to update the data in this data set. And we can set it to the first name and the second name, or first name and last name here. Accept changes is sort of like a commit. It says, because before here we could actually reject the changes and roll them back. So what I actually want to do here now is I want to run this program. And let's go to right here. Now watch what happens. So I'm going to do F10, execute this code. Now if I highlight DS, I can drop this down. If I want to, I can navigate to things like tables, and you can see the count and things like that. Or we can go to results view and see if I click that, see how it actually shows me the table. Another thing I can do is just highlight this, and the very first thing, just click this little view button. And so it's just kind of a nice way to show you exactly the data that's contained within our table, within our data set. So this is the data that got changed. So on the application, if you were to click on row 2 and then type in new username or first name and last name, it would update this in our data set. So if we come back over here and let's scroll down for our update click, and now we'll just change this A, B, C, D, E, F. Let's actually click on this one here. Now when I click update, you can see here's ABC, here's DEF, here's our data set. And so we're going to update this second row with data. So if I step through here in my data set, when I click view, you can see now I've updated that, and this is in memory. Again, it's disconnected from the database. If we want to update the database, we'd have to then have an update statement that goes back to the database. We'll learn that another time. Now here for add row click, this one here, we're just going to get the values that the user created. Now this data set, our tables, new row. Now if you remember, in our data set it had columns and rows already built into it, so it had a structure built. So if you say new row, that gives you the columns you need for the structure of this data row to hold this new row that we're going to create. So the first column in our data row, I'm just making up a value here. This could be 1, 2, 3, 4, whatever. I'm just making up an ID here. In the real world, you'd have to create a unique ID. Then I'm adding the first and last name to the second and third column in my data row. Then down here, I'm saying access the data set, the first table, rows.insert at, here's the row that we just created, our data row, and insert it at this index, whichever was accepted, or whichever was selected, and then we accept the changes. When we're deleting, we want to make sure that there is a current row. We get the row index. Now this is deleting equals true. We'll come back to in 1 second. We take our data set for our data table, and we say for this row dot delete. Then we have to accept our changes and then say is deleting equals false. So what I'm going to do is I'm going to set a breakpoint right here, and now I'm going to come back up here to our other method called DataGrid view current cell changed. So think through why I had to do this. Current cell changed. Well, if I were to delete a row, it automatically changes which cell is selected. So this event also gets raised when we delete a row from our data set. So this is a very likely case where you'll have a bug in your code. And how did I know? Well, I've just done it so many times and had so many bugs in my code. This is something I learned to do. So let's just go ahead and run through that, step through that. So let's say I'm going to delete this given row here. When I click delete, I'm going to say is deleting equals true. Now watch what happens when I run this statement, F10. See how it jumped me up to this? Why? Because I'm deleting. And so it's updating that data set, which is bound to our data grid, so that another cell got selected. So is deleting true? Yes. So just don't do anything. Just skip over that code. Now, you'll notice is deleting is still true because again, this method is getting called based on what it's displaying. So I'm just going to do F5 again, and now it deleted that row in our code. So again, there's some tricky stuff, and you always have to be careful to understand, why, we're handling certain events and what events, when those events will get called based on what happens in your code. So that's why I had to set this to true here. When I call this, it executes the code above, and then I reset that variable after I get past that code there. A little bit tricky, but I mean that's programming for you. Next application I want to talk about is DataGrid view adding objects. So if we come over here and run this application, what we've done is I've got another DataGrid view, and this one actually isn't even using a database. We're just showing you how we can create some data. We're going to create a list of objects, bind it to a DataGrid view, and then I'm showing you how you can select data from that DataGrid view, pull out that object's data down below, and display it. Or click a button and actually delete that data from the row. Now this is all in memory. We're just pretending as if we're getting data from the database to be able to display here. So let's start at the top. So let's introduce a new concept here. This is called a binding list. So in the past we had used lists before, generic lists, but now since we're actually binding to UI components, and we may want to update this list where we may want to add objects to it, we may want to delete objects from it, and we want those changes to be reflected in our DataGrid view. And so we're going to use a binding list because that generic list has properties built in that sort of say, hey, my objects have changed, UI, you need to update. So it has that built in for you. But it's just a generic list. And you notice we're creating a list of employees. So what I've done is just down here at the bottom, I've created another class called employee. It has an ID, a first name, and last name. That's all there is to our employee. So essentially we're thinking, oh, hey, there's an employee table maybe in our database. We need to pull that data back. We'll fill up a list of objects of these employees and then bind that list to our DataGrid view. So let's create our list of employees of type binding list. Now I'm going to show you how to customize the DataGrid view a little bit more. So again, our DataGrid, we can just bind it and it would create the columns for us, but maybe we want to be able to specify the columns up here. We want to maybe put text boxes over here, but buttons here. Well, how do we do that? Well, you have to actually customize each column. So I know that I'm going to have 4 columns. Why? Well, I've got an object here that has ID, first name, and last name, and I want to add in a 4th column for a button. So that's how I know how many columns to create. So first, I'm going to create 3 text box columns. So you can see there's a DataGrid view text box column. Just instantiate 3 of them and add them down below to my DataGrid view. I'm also creating column 4, which you'll notice is a DataGrid view button. Well, obviously you can see that that's this button that I'm creating right here. So I wanted to put a button in there so it's easy for the user just to click right on that row and delete that row. Now down here, I'm going to start filling up the properties for each of my columns. So first in column 1, I'm going to set what's called data property name. So what this says is they're asking us, hey, for our column, I know you're going to bind some data to us. So what property do I call in order to display the data? And I'm saying you're going to call the property ID, which I created down here. Here's the property. And so it just calls this, which calls the get and returns the ID, and that's what it displays. Down here it'll be first name and last name. So you can see from my other columns, so in this one here, I have data property as ID. Here it's first name, here it's last name. The header text is what's displayed to the user, and then this is just the name of the column, so we're just going to name it. On our second column, I'm actually setting some other properties about resizable or sort mode. Again, just some different things that you can set. Now our 4th column is unique because this is the one where we're deleting our employees. And so what you want to do here is you want to set this text property. Then you also want to set this use column text for button value. So if I were to comment this out and run the code, see how that actually comes up blank now? That's not what we want. What we want is something helpful to the user. See, delete this employee. So that's how we can set that text there. And also, if you want to, you can set the column width. Now we take our DataGrid view and we just add all of our columns into it. So we're just creating that structure for how we can hold the data. Now we're just going to instantiate 3 different employee objects. Now this code, again, normally all of this code through here would be in some business logic class where we'd call the business logic class and say, go get the data from the database. For each object, for each row, instantiate a new object and fill up that object's data. So each row, we just instantiate employee object and fill up the data. Here I'm just hard coding in some data, so we have data to work with for 3 employees. Now in my binding list, I just add those 3 employees. Again, all of this should be in a business logic. Here I'm saying don't auto-generate the columns. Why? Because I spent all this time creating the columns manually and I want it displayed that way. And then down here we can set our data source to our list. So that initial code, when I run it, does this. Now remember, even though we didn't use a database, we're binding the data source to our list of objects. So our code doesn't care where we got the our data from. It could be a file, it could be a database here, or just hard coded like we've done it here. Now that DataGrid cell click, so I've just handled the event right here, cell click. And the first thing I want to do is I want to pull out the employee object for whatever row that I'm referencing. So remember, I've got a list of employees. So I've got all the information I need about every employee as an object for each row. So what I can do is I can say, hey, my data grid, I've got a collection of rows, however, pull out the row index that was selected. So see how there's this argument passed in? If I highlight row index, you can see it's going to give you the selected row for the event that occurred. Data bound item. Now this is an object type. So this code right here says, hey, give me the selected object that was bound to for this given row. I know it's an employee, so I just cast it to my employee object, and now I've got my employee. I always want to make sure it's not null because, again, you could always select this extra row down here. And then from there, if it isn't null, we want to figure out if they've clicked that delete button. So we need a way of figuring out, hey, did the user click this delete button? So we come over here and we say, was our employee null? If it wasn't null, then what we do is we say, okay, here's this event that we talked about, and let's get the column index. Is our column index equal to the same index where our delete employee button is at? We could have said e.columnIndex, equals 4, or whatever. But I'm making it a little bit more dynamic in case we wanted to add other columns later on. So if it was the delete button, basically, inside of our list, we can remove this object, or we could have removed at a given index. So we're just saying delete this row from our binding list. But when we do this, the view of our DataGrid view here is automatically updated because we used a binding list. So it has that communication back and forth. Now, if they didn't click the delete button, then we now have our employee object, so we can just display that data to the user. So that's why clicking this can fill up our data down here. So this is a very key concept that I want you to grasp. So for almost all applications where I'm dealing with a database, I've got some kind of binding list or list structure that what I do is I call my business logic class. It goes to the database, gives all my data back in a data set. I loop through each row in my data set and I create a object of whatever type, whatever class I'm using, in this case an employee. I instantiate the employee object, fill it up from that row's data, add that to my list, and then I would just have all of this should all be one statement that looks like this. So here I would call my business logic and say get employees, for example. That method would return this list and just bind it right here. And that's all I would have to do as far as my UI is concerned. So again, that's a very key concept to kind of learn that paradigm. All right, this is our last example here. And so in this one, this is going to help you with your assignment for our airline system. And so I'm going to show you a few different concepts for how to select and display data. The first one is if you select a user up here, it's going to turn their seat green down below. The next way is if you run this application and you were to click on a red seat, it's going to select that user in the combo box. So these are two things that your assignment has to accomplish. So first, let's take a look at how this code works, where again, all of this should be in a separate class. I'm doing it here to keep it simple. I'm selecting all the passengers from my database that are on this flight ID 1. So give me all the passengers that are on this given flight. Execute that SQL statement and it fills up my data set. So let's go ahead and just walk through that. So you can see as I press F10 and I take a look at my data set, look at the view, you can see here are the rows that were created. And so with those rows being created, I now have all the data associated with this flight from my database. So now that I have that, I can now loop through and instantiate a passenger object for each row in my data set. So again, let's take a look at this. So if I come in here, highlight this, you can see what I'm doing is for each of these rows, I'm going to instantiate an object and fill it up with the data in the columns. So I instantiate a new passenger, and you can see I'm just filling up those properties with each item that's returned here. So if we were to look at my passenger class, you can see it's very simple. It just has the ID, first name, last name, and I made it even simpler. I actually just made these, public attributes. I was a little lazy there. And now this is very, very key. I've overridden the toString method for my passenger class because in a combo box, this is what it calls for what it should display to the user. So let me go ahead and run this. So see how this combo box is displaying the name? Well, how does it know what to display? This is an object. This is a passenger object. Well, that's what that toString does for us. It says, hey, combo box, this is how I want you to display the data for each of these passengers. So that's what the constructor does. Now let's talk about the seat click. So when I run the application, if I were to click a red seat, it should select it in our combo box here. So we're handling the seat click event for all of the different seats. So if I come over here to my different seats, you can see that they all handle the click event and they all call the same method called seat click. So what I can do is this object is the label that was clicked. So I just have to cast it back into a label. Then what I can do is I can say if the label.backColor is red, because I don't want to do anything if it's blue or another color. And you can see I just skip everything if it's red. Or sorry, if it's not red. If it is red, I turn that label green. I can use that label's text in order to fill up the seat number. Now what I can do is I can loop through the combo box's items, or if I wanted to, I could have made a list of passengers up here and I could have created a class level attribute. Or another thing I could have done is this data set, I could have made this a class level variable and I could have looped through it in order to get to the passengers. But I knew that my combo box already had all those list of passengers in it. So I just said, okay, loop through all of my passengers. This next statement, I want it in a passenger object because items is just objects. Well, I want to loop through and get each passenger. So this is looking at the first passenger in that combo box. And I say, okay, is the seat from the label clicked, is that equal to this passenger seat? Well, if it's not, don't do anything. But if it is, set the selected index of the combo box to that passenger. So that you'll notice that here's seat 4, so when I click it, John Hess was in seat 4, so that's why it selected that index. So the next part of this assignment is where we're going to actually select one of the passengers from the combo box. So if I come to my combo box here, you can see I want to change that selected seat to green. So what we can do is we're having the selected index change of our combo box. So we say combo box, give me the selected item. Now again, this is an object, so we have to cast it to a passenger. So now we have the passenger object that was selected. And now we have all that information, so we can get their seat, for example. Next, we can loop through all of the controls in this panel from the seat. So let's come back here and show you what I did. You'll notice I created this panel here, and inside that panel I added the labels. Why did I do that? Well, I wanted to be able to loop through all of the controls that are within this panel. So how do I do that? Well, I use a for each statement, and I say, okay, in my panel, dot controls. So this gives me all of the controls. Now you'll notice that because I created it, I know that there's only labels inside here. Now if there was buttons and text boxes and other controls, I'd have to be careful, but there isn't. I created it, I know. So that's why I can say automatically just cast it, so for each label. But again, this would throw an exception if there was other types of controls in my panel. So I'm saying loop through each label inside my panel, automatically just change it to blue. I'm essentially resetting it back to blue. And then I say, hey, does that passenger seat equal the label that was clicked? If it was, then hey, that's the passenger seat, so turn it to green. I know we covered a lot in today's lecture, and just remember, you can just go ahead and use our data access class and just plug it right in and start using it, but at least try to get your head wrapped around that code. The other main concept to learn is the idea of going to a database, pulling data back into a data set, looping through the rows in that data table, filling up some sort of list of objects, and then binding that list to some sort of UI component like a combo box or a list. So if you have any questions, just let me know.